Hey guys, this is Arvind. In this video, we'll be solving f of x is equal to x. Already we solved this problem, but in this video, we'll be solving this in complex form of Fourier series. The Fourier series is of the form f of x is equal to c naught plus n is equal to 1 to infinity cn e power in pi x by l plus summation n is equal to 1 to infinity c minus n e power minus in pi x by l. Now we need to find these three constants c naught, cn and c minus n. c naught is equal to 1 by 2l integral minus l to plus l f of x dx. Now substituting the values 1 by 2 pi minus pi to plus pi, f of x is given by x and dx. Since x is an odd function, this would become 0. The cn is equal to 1 by 2l integral minus l to plus l f of x e power minus in pi x by l dx. Now substituting the values 1 by 2 pi integral minus pi to plus pi x e power minus in pi x by l. Now we are substituting the value of pi in the place of l. Pi and pi would get cancelled dx, which is equal to 1 by 2 pi integral minus pi to plus pi x e power I n x dx. Since we have two functions, we are doing integration by parts. U is equal to x, dv is equal to e power minus in x dx. Differentiating, you will be getting du is equal to dx, v is equal to integrating dv, which is nothing but e power minus in x divided by in minus in. U dv is equal to uv minus integral v du. Now substituting these values in the u dv formula, taking in, which is a constant as common, while integrating we got e power minus in x divided by minus in. Now we will be applying the limits. Minus 1 by 2 pi in, pi e power minus in pi minus of minus, so plus pi e power in pi plus 1 by 2 pi in e power minus in pi minus e power in pi. Now taking pi as common, we are left with this. Since I square is equal to minus 1, sorry, I done a mistake, this is not plus, this is minus, since we took this minus in common. Now this minus and minus would become plus. The next step would look like this. Minus 1 by in into e power minus in pi plus e power in pi divided by 2 plus, we are grouping in this form. We know from while we are deriving complex form of Fourier series, we used this e power minus in x plus e power in pi divided by 2 is equal to cos n pi, e power minus in pi minus e power in pi divided by 2 is equal to I sin n pi. We are substituting these values in this equation. We know that sin n pi is equal to 0, so this would get cancelled out and we are left with cn is equal to minus 1 power n divided by minus in. Now we are finding c minus n, which is equal to 1 by 2l integral minus l to plus l f of x e power in pi x by l. We are substituting the values 1 by 2 pi integral minus pi to plus pi x into e power in x into dx. Since we have two functions, we are doing integration by parts. Putting u is equal to x, dv is equal to e power in x dx. Du is equal to dx, v is equal to e power in x divided by in. Now substituting these values in udv formula. Now we are applying the limits, taking a constant in outside. This in will come outside and become in squared. Now we are taking pi as common. Pi would get cancelled. Since I squared is equal to minus 1, we are grouping this in the just like the previous case. Sorry, I have done a mistake. Here this is plus. This is not minus. E power in pi plus e power minus in pi divided by 2. Minus and minus would become plus 1 by I squared n squared pi I power e power in pi minus e power minus in pi divided by 2. We are substituting this value just like in the last case. Since we know sin n pi would become 0, the remaining term is this. Now applying these values in the complex form of Fourier series, we would get f of x is equal to minus 1 by I of e power ix divided by minus 1 plus e power 3ix divided by minus 3 plus e power 5ix divided by minus 5 plus and so on. Minus 1 by I, in the same way this would look to minus 1 by I of e power minus ix minus e power ix plus 1 by 3 of e power minus 3x minus e power 3ix plus 1 by 5 of e power minus 5ix minus e power 5ix and so on. We group this term, both of these terms. Since 1 by I is equal to minus I, this would become minus 1 into minus I. Since this term would look like this, the missing 2 and I can be multiplied to obtain this formula. So that the equation would look like this. And the final answer is, which can be written in the form of 2 into summation n is equal to 1 to infinity minus 1 power n plus 1 divided by n into sin nx. Just like in the previous case, we got the same answer in both the methods.